Dear students, once again welcome to your favorite channel TKG PhysicsClasses, and I am come back with another part for your vector chapter. All of you know we just completed 3 lectures related to your vector chapter. Lecture number 1, that is basic part of vector. Lecture number 2, that is the vector addition law, and lecture number 3, that is the analytical method of vector addition. That means in vector 3, in lecture 3, we derive the magnitude and direction. The magnitude of direction of a resultant vector, and this is our lecture number 4, and in this lecture we will discuss the basic part, that is resolution of vector. After that we learn orthogonal trade of unit vectors, and third one, that is the rectangular component of a vector, and then we solve some important numericals related to this class. So once again welcome to your channel, and now open your copy and write down the notes. Okay, so first of all you have to know about resolutions of vector. What is the meaning of resolution? This is our definition. You just see, it is the process of splitting of a vector. It is the process of splitting of a vector into 2 or more components, into 2 or more vectors, in such a way that their combined effect is the same as that of the given vector, and the vectors into which the given vector is splitted is called the component vectors. Suppose you have 2 vectors, vector A and vector B. This one vector A and this one represent vector B, and vector A and vector B represent the 2 adjacent sides of a parallelogram. Then what is the resultant? All of you know the resultant will be this diagonal of that parallelogram passing through this common point. That is, here this, suppose this is O, this point P, this point Q, and this point is S. So here OS is represent the resultant of these 2 vectors, vector A and vector B. This is our addition law. And resolution of vector, you can say, that is the just opposite of addition law. That means here it is the process of splitting of a vector. Suppose this is our vector, OS is represented vector R. Now you just split this vector R into 2 or more vectors. Here R is splitted into 2 vectors. One is OP and another one is, that is OQ, which is named as B. So here R vector, which is splitted into 2 vectors, that is vector A, which is represented by OP, and vector B, which is represented by OQ. So this method is named as resolution of a vector. If I say vector A plus vector B, this represent the addition. A plus B gives the resultant vector, which is named as R. But suppose I am considering a vector which is represented OS, that is R. Now here R is splitted into 2 vectors. One is A, which is along x axis, and another one is B. You just consider this is as y axis. So here R is splitted into 2 vectors. Suppose there are 3 axes, x axis, y axis, and 3 z axis. So when a vector R is splitted into 3 axes, then 3 axes, then you can say these R are splitted into 3 vectors. So this is the resolution of a vector. Okay, suppose a vector A is directed along this direction. You just consider this is x axis, this is y axis, this is vector A. Vector A, which is represented by OP, and this vector is making an angle theta along x axis. This is our x axis and this is our y axis. Now here vector A is splitted into 2 vectors. Vector A has 2 components. Vector A has one component which is along x axis, and vector BA has y component, which is named as vertical component. Okay, suppose this is our vector A, this is our vector A. So when a vector A is directed along this direction, that means this vector has some component which is along this direction, along x axis, and this vector has some component which is along this direction, this y axis. When a vector A is directed along this way, that means this vector is moving along x axis some distance, as well as this vector is going along y axis as some distance, along y axis, that is in vertical line, and this vector is going along this way, that is along x axis. So this vector consists of two vectors, one is horizontal component, this one is horizontal component, and another one is, this one is named as vertical component. So this is our resolution of a vector. Resolution of a vector, that means the splitting of a vector into two or more vectors. So when vector A, this one, vector A is directed along this way and makes an angle theta with this x axis and this is our y axis. So obviously this vector has some component which is along x axis and this vector has some component which is along y axis. Now what is the value of this component? Suppose this is named as ax vector and this is named as ay vector. Now what is the value of ax vector? Ax vector is the vector part of a vector along x axis and ay vector is the vector part of a vector along y axis. That means A is the resultant of ax vector and ay vector. You just consider parallelogram law. This vector ax along y axis and this is vector ay along z axis. So the resultant vector gives this vector A. Okay. So we can say vector A is equal to ax vector plus of ay vector. Now ax vector, that means this vector has some magnitude value. Ax vector, that means this vector has some magnitude value. Similarly ay vector, that means this vector has some magnitude value. Now you have to find out what is the magnitude along this direction and what is the magnitude along this direction. Suppose this is O, this point is represented by P and this point is represented by Q. Now you have to find out the value of OQ. Okay. So you just consider from triangle OPQ cos theta. What is the value of cos theta? Cos theta, that means base by hypotenuse. This is our base OQ and this is our hypotenuse OP. So base OQ divided by OP. So from here you can say OQ, that is equal to OP cos theta. What is OP? OP represent vector A. So in the place of OP you can write A and this is our cos theta. Okay. So OQ, that means A cos theta. So A vector has some component which is along x axis and which is in magnitude value, which has magnitude value, that is A cos theta. And similarly you just consider sin theta. What is the value of sin theta? Sin theta perpendicular this one PQ by hypotenuse, that is OP. So from here you can say PQ is equal to OP sin theta. So you know OP, that is represent the magnitude value of resultant vector. So that is A and there is sin theta. So PQ, that is A vector has magnitude, PQ, that is A has one component, a y component, which is named as A sin theta. So A vector has two component, the horizontal component that is along x axis which is named as A cos theta, and A vector has some vertical component which is along y axis is named as A sin theta. But not always. When this angle is given, suppose A vector is making an angle theta with this y axis. Now in that condition this component will be A cos theta and this component will be A sin theta. You just calculate from this triangle, you just calculate, easily you will get this component will show A cos theta. That means the angle along with this axis always gives the cos value and the perpendicular with this axis is always gives the sin value. Okay. So this is our resolution of a vector. Now you just think the real example of resolution of a vector in our life, that is walking of a man. This is our pictorial representation. Suppose a man walking in this way, that means they applying a force on the ground F along this direction. We are applying a force on the ground along this direction, not vertically. So when we are applying a force along this direction, according to Newton's second law of motion, there is always an equal and opposite reaction force. That means this force always shows an equal magnitude of reaction force. So this is our reaction force which is directed along this way. Now this reaction force has two components. this reaction force has two component. Suppose if we consider this reaction force making an angle theta with this rod, with this line, so this component will be r cos theta according to resolution of a vector. This r component is split into two way. This one is r cos theta because this is our angle. So this one gives the horizontal component, and this one is named as r sin theta. This is named as r sin theta, which is named vertical component. So here r splitted into two way, one component that is r cos theta along this rod, along this horizontal line, and one component r sin theta along this vertical line. Now you just think, what is the purpose of r sin theta? A man weight is directed along downward, that means r sin theta, which is equal to mg, that means the r sin theta component weight, the r sin theta components give the significance of balancing our body. R sin theta components, the work of r sin theta components, the balance to balance our body, and r cos theta along this direction, that means r cos theta, with the help of r cos theta we are moving forward. Obviously when there is a friction, when this friction is more than, when this component is more than the frictional force, this r component moves forward. So this resultant r has two component, r cos theta, with the help of r cos theta we are going forward, and the another component that is r sin theta, which is named as vertical component, with the help of vertical component we are balancing our body. Okay, so this is our resolution of vector. Now we will learn unit vector. All of you know the basic part of unit vector. Here we learn unit vector, then after that we learn orthogonal trade of unit vector. Okay, so what is unit vector, students? All of you know a vector always has magnitude as well as its direction. Suppose a vector A, so a vector A is represented in this way. It has magnitude value, which is represented by mod under A, and it has direction, which is represented by A cap. Here A cap is represent the unit vector of A vector. A cap is represent the unit vector. This one gives the unit vector of vector A. And what is the purpose of unit vector? Unit vector, the only purpose, that is, it gives the direction of any vector. Here A cap gives the direction of a vector. In general, we represent unit vector by the symbol of n cap. You just consider a vector. This is our vector, vector A of magnitude, suppose 1, this is 1, 2, and this one is 3. This is our vector A of magnitude 3. So obviously we can say vector A is equal to magnitude 3, and this is directed, suppose this is x axis. Okay, so this is vector A of magnitude 3, and to represent the direction of a vector along x axis, we use a unit vector which is named as I cap, which is named as I cap. I cap gives the direction of a vector along x axis. Same way, if we consider a vector A along y axis, magnitude same, this is 1, 2 and 3, but this is directed along y axis. So you can write a vector that is equal to magnitude 3, but its direction y axis, and y axis direction is represented by j cap. Same way, if a vector is directed along z axis, it is represented by unit vector which is named as k cap. So here I cap, j cap and k cap, I cap, j cap and k cap, I unit vector along x axis, j unit vector along y axis, and k cap is the unit vector along z axis. This I, j, k cap is named as orthogonal trade of unit vectors, or you can say base vectors. And you know always unit vector has magnitude, that is 1. Now, what is the unit vector along negative x-axis? For representing unit vector along negative x-axis, you have to write minus I cap. For negative y-axis, minus j cap. Same way for negative z-axis, that is minus k cap. So, I, j, k are represent the unit vectors along x-axis, along y-axis and along z-axis respectively. So, this is our orthogonal trade of unit vectors. Suppose one question given, a vector of magnitude, you have to represent a vector of question given magnitude value 5 which is directed along x-axis and magnitude value 10 which is directed along y-axis. A vector A which is magnitude value 5 along x-axis and magnitude value 10 along y-axis. You have to represent this vector A. So, you write vector A, that is equal to along x-axis vector you represent Ax vector and along y-axis you represent by Ay. Now, you just see along x-axis magnitude value 5. So, Ax vector, that is magnitude value 5, and you know along x-axis the unit vector is named as I cap. So, this one is I cap plus along y-axis magnitude value 10. So, this value gives 10 and along y-axis unit vector is named as j cap. So, this is j cap. So, here A vector is represented by this way. Okay, take another example. Suppose A vector has magnitude, you just write here magnitude 4 along x-axis and here magnitude you write 5 along minus y-axis. What will be the answer? Here answer will be 4, magnitude value 4 along x-axis, that is I cap, but here 5 along minus y-axis, that means here you have to write minus magnitude value 5 I cap. This is magnitude value 5, but direction is along negative y-axis, so you have to write minus I cap. Okay. Take another example. Suppose this vector has magnitude value 4 along x-axis, magnitude value 5 along minus y-axis and magnitude value 10 along z-axis. So, this one will be plus of 10 along z-axis, that is directed by k cap. So, this is our general expression. A vector is directed along x-axis, along y-axis and along z-axis. Okay, and I, j, k is named as the orthogonal trade of unit vectors. Now, students, we have to solve rectangular components of vectors. Write it down first. Our third part, which is named as rectangular components of a vector. Rectangular components of a vector, that means the splitting of a vector into two ways in general for two dimensional. Suppose this is our x-axis and this is our y-axis, and a vector A is represented by OP. This is our vector A, and this vector is making an angle theta with this x-axis. Okay. So, we learned that according to resolution of a vector, a vector is represented, has two components, one component is along x-axis and another component is along y-axis. Similarly, we learned according to parallelogram law of vector addition, that is, suppose this is vector Ax vector and this is a y vector. So, according to parallelogram law of vector addition, we write Ax vector plus a y vector, which is equal to the resultant, that is named as a vector. Okay, write it. So, a vector is represented Ax vector plus of Ay vector. What is Ax vector? Ax vector is the vector which is directed along x-axis and Ay is the vector which is along y-axis. Now, you write Ax vector, generally a vector has magnitude. So, Ax vector has magnitude which is named as only Ax, but there is no direction. This is a magnitude value of Ax vector, and Ax vector has direction which is along x-axis, and this is represented by I cap, plus of Ay vector has magnitude value which is named as Ay, and this is directed along y-axis, and y-axis unit vector direction, that is j cap. So A vector is represented like this way, Ax I cap plus Ay j cap. Suppose a vector has magnitude along x-axis 3 and along y-axis 6. So it will be represented along this way, 3 I cap plus 6 j cap. Okay. Now you find out the value of Ax and Ay. What is the value of Ax and Ay? You just consider this one OP and you just consider this is Q. So this is angle theta. So the value of cos theta will be this one OQ by OP, OQ by OP, that is OQ, that means Ax, and OP, that is the magnitude value of A, that is A. So from here you can say Ax is equal to A cos theta, this one Ax, the value of Ax, that is equal to A cos theta. Same way you just write sin theta PQ divided by OP. So from here you can say PQ, that is equal to OP sin theta, and you know the value of OP. OP is the magnitude of a vector, that is A sin theta. Okay, and this is our AY PQ. This represent y axis. This is our AY. So Ax has component A cos theta and Ay has component A sin theta. Okay, this is our horizontal component and this is our vertical component. Now suppose you named it, this is equation 1 and this is equation 2. Now you just square this equation 1 and 2. Ax square, that means A square cos square theta, and Ay square, that means A square sin square theta. Okay, now you just add this equation. Suppose this is equation 3, this is our equation 4. Adding equation 3 and 4, what will happen? Ax square plus Ay square, that is equal to A square cos square theta plus there is A square sin square theta. Okay, now Ax square plus Ay square, that is equal to here A square common, sin square theta plus of cos square theta, that is 1. So Ax square plus Ay square, that is equal to A square. This value gives 1. So from here you can say A is equal to root under Ax square plus root under Ay square. This is another form, and this form, this equation gives the magnitude value of a vector. How to find out the magnitude value of a vector? So this is our equation to finding magnitude value of a vector, that is root under Ax square. What is Ax? Ax is the magnitude value of a vector along x-axis plus Ay square. What is Ay? Ay is the magnitude value of a vector along y-axis. I am considering this one, magnitude value of a vector along x-axis 3, magnitude value of a vector along y-axis 6. So this one will gives root under 3 square, that is 9, plus root under 6 square, that is 36. Okay, so this one will be root 45. So in this equation we will find out the magnitude value of A. In this equation we will find out the magnitude value of a vector along x-axis. In this equation we will find out the magnitude value of a vector along y-axis. Note down students, this is a very important part, Ax, Ay and A. Now third part, this is our figure, this is the resultant R. Suppose this angle is make an angle theta. Now you just find out tan theta. What is the formula of tan theta? Tan theta, that means perpendicular by base. This is our perpendicular, that means this one perpendicular, that means Ay. This is vertical line, this one represent the vertical line, and the vertical line magnitude value is component represented by Ay, and this is our base, that is the horizontal line, component is represented by Ax. So theta is equal to tan inverse Ay by Ax. So this is our formula for finding theta. Suppose tan theta is equal to, I just considering Ay, that is 6 and Ax, that is 3. So tan theta is equal to, this value gives 2. So from here you can say theta is equal to tan inverse 2. Okay, so this part is very important, students. The formula of Ax, the formula of Ay, the value of A, that is the magnitude value of A, and this value, that is the formula of tan theta. With the help of these equations, we solve some important numericals related to this part. And there is another part, students. If this A vector is splitted into 3 axes x, y and z, then we can write the general expression of A, that is like this way. So, for 3 axes, A vector is represented by this way: Ax I cap, Ay j cap, Az k cap. Same method. Ax is the magnitude value of A vector along x axis, Ay is the magnitude value of A vector along y axis, and Az is the magnitude value of A vector along z axis, and I, j, k is the orthogonal unit vectors. And what will be the formula for finding the magnitude of A vector? Same method. A is equal to, for 2 coordinates, this is the formula x square plus ay square. So, for 3 coordinates, this formula becomes ax square plus ay square plus az square. Method same. Okay. Now, we will solve some important numericals related to this formula. Okay. Solve it. So, students, this is our some problems related to this topic. You just check first one. First problem given: a force is inclined 60 degree to the horizontal. Draw the diagram first. This is problem 1. A force is inclined, a force F, suppose this is F, which is inclined 60 degree with this horizontal line. And if the rectangular component in the horizontal direction given 50 Newton, that means Fx is given 50 Newton. You know the horizontal direction rectangular component is named as Fx, and the vertical component is named as Fy. So, here Fx given, that is 50 Newton, and theta given, that is 60 degree. You have to find out the magnitude of force, that means you have to find out F, and then its vertical component, that means you have to find out Fy. Okay. So, you know the horizontal component which gives the cos theta value, and the vertical component which gives the sin theta value. So, you just write this value. Fx can be written as F cos theta. So, here F given 50, that is Fx given 50, F you have to find out cos 60. So, here F is equal to 50 divided by cos 60, 50 cos 60 value, that is half. So, this one becomes 50 into 2, that is 100 Newton. Okay. So, the magnitude of force, that is 100 Newton. Now, you have to find out the vertical component. Write it. Vertical component, that is Fy, and you know the Fy, that is F sin theta. So, F, that is 100, and sin theta given 60, 160, that is 100 sin 60, that is root 3 by 2. So, this one gives 50 root 3 Newton. Okay. So, this is our application of resolution of a vector. Horizontal component cos value and the vertical component gives the sin value. Okay. Now, you just at first you solve problem 3, okay, then we will solve problem 2, problem 3, problem 4, then we will solve problem 2. Problem 3, you just check, find the magnitude and angle with the x axis, positive x axis of the following vectors. This one vector, write it down. Sorry. Problem 2 given, you have to find out the magnitude. Okay, vector A given, that is 4 I cap plus 3 j cap. You have to find out the magnitude, that means here you have to find out mod under A, or you can say A, and the angle theta. So, you know the formula. How to find out A, mod A, that is mod A is equal to root under Ax square plus Ay square. You know what is Ax, this value, Ax represent the x component of A vector, that is 4. So, 4 square, that is 16, Ay square, that is 3. So, this one is 9. So, root 25, that gives 5. So, the magnitude value of A vector here, that is 5. Now, you find out theta. You know the formula, tan theta, that means Ay by Ax, this one. this one a vector, this one ay, this one ax, this one is theta. So tan theta, that is equal to this value ay by this value ax. So here ay, that is 3, and ax, that is 4. So this value gives tan theta, that is equal to 3 by 4. So theta is equal to tan inverse 3 by 4. Okay. So this is our problem 2. There is another part for problem 2. You have to find out for b vector, that is magnitude and angle. Okay, find it, same method. Okay, this is your homework. Problem for b, so you just see there is 2 minus 2 I cap, that means here will be minus 2 the square, that is 4. Okay, you can solve it. Now you check problem 4. Find the unit vector in the direction of a vector. Solve it. Problem 4, that is you have to find out unit vector in the direction of a vector. In general, a vector which is represent magnitude of a into a cap. Here a vector given, a vector value given, that is 3 I cap plus 4 j cap. You have to find out this unit vector in the direction of a vector, that means you have to find out a cap. So what is the formula of a cap? A cap, that means a vector divided by mod under a. Mod under a, that means the magnitude value of a vector. So you just find out the magnitude of value of a vector, that is ax square plus ay square. What is ax square? A, that is 3ax 3. So 9 plus ay square, that is 4, 16. So this value gives root 25, and root 25, that means 5. So the magnitude value of a is 5. So what is the value of a cap? A cap will be a vector. So in the place of a vector you write 3 I cap plus 4 j cap, and in lower side that is 5. So 1 by 5 3 I cap plus 4 j cap. So you can write 3 by 5 I cap plus this one will 4 by 5 j cap. Okay. Now solve problem 2. Problem 2 given, find the unit vector parallel to the resultant of two vectors, that is a vector and b vector. Write it down first. A vector given I cap plus 4 j cap minus 2 k cap, and b vector given 3 I cap minus 5 j cap plus k cap. You have to find out the unit vector parallel to the resultant of a and b vector. At first you have to find out the resultant of a and b vector. In general we write the resultant of a and b vector, that is a vector plus of b vector, that is the resultant r vector. So write it down, I cap plus 4 j cap minus 2 k cap plus of 3 I cap minus 5 j cap plus k cap. So this value gives I cap plus 3 I cap. So this one will be 4 I cap minus 4 j cap, and there is plus minus a minus 5 j cap. 4 j cap minus 5 j cap, that is minus j cap. This one minus 2 k cap and plus, that is minus 2, and there is plus k cap. So this one will be minus k cap. This is our resultant vector r. So this is our first part. Find the unit vector parallel to the resultant of vector a and b. So you at first you find out the resultant of a and b, that is r. Then you find out the unit vector. That means here you have to find out the unit vector of r. So you know r vector, that is equal to magnitude value of r into its unit vector. So its unit vector r cap will be r vector divided by its magnitude value. Now you know the value of r vector, that is I cap 4 I cap minus j cap minus k cap, and you know the formula of finding the magnitude value of r, that is ax square plus ay square plus az square. Here ax, that is 4, so 4 square, that is 16, plus ay, that is minus j cap, that means minus 1 the whole square. So this one gives 1, and there is minus k cap, that is magnitude value minus 1 the whole square. So this one also gives 1. So 4 I cap minus j cap minus k cap divided by root under 18. That means you can say this one will be 4 I cap minus j cap minus k cap divided by 3 root 2. So this is our unit vector which is parallel to the resultant of A and B. That means here you have to find out at first the resultant of A and B, then you have to find out this resultant's unit vector. Okay. So students, this is our some examples related to this part, and you go to your book, you go to your NCERT book, your any type of physics book, you just check, there are several types of problems, go solve it, and if there is any problem, let me know through this comment section. Today I am ending here. Meet you soon in your next class. Till then, bye bye.